Good afternoon. My name is Carla Garza, and today we're going to be talking about the 5 main causes of microevolution using a finger to describe each cause. For starters, we're going to talk about the pinky. So the pinky is the smallest finger that we have, so we're going to be thinking about size, more specifically, smaller sizes. So we're thinking about a population getting smaller. So population shrinkage. The example in the video that we have provided to us describes an epidemic. So for the sake of the assignment, I'm going to do the same. Suppose that we have a population of 100 people. An epidemic occurs and then we have 4 people that remain. Mind you, this is an extreme circumstance. This is not likely to happen, and this is only for the sake of the example. 100 people to 4 people that remain. These 4 people that remain are going to be the genetic blueprint for the future of that population. They're going to determine how a species will look, how the species will maneuver, their style, their strategies, their strategic survival instincts will be based on these 4 people alone. So this finger represents chance and size. The second finger we're going to talk about is the ring finger. So ring finger, we're going to think about marriage. We're going to think about marriage. So one of the questions that I have to answer for the sake of this video is, how are eye color and evolution connected? So this is going to tie back into the marriage thing. Eye color and evolution are connected because of genes, migrational patterns, and environmental adaptations. So what this means is, suppose that I like people with white hair and blue eyes. So let's say I moved to Miami. I'm from Boswell, I moved to Miami. My genes are being introduced to the area. I am not native to Miami, so my genes are new. I am increasing the genetic flow of the area. I'm also going to see my genes become dominant. Brown eyes are dominant over blue eyes. So within future generations, I can likely see my eye color being present in the environment. Another thing is environmental adaptations. So what this means is more targeted towards animals. Suppose that an animal has bright colored eyes and the same species has darker colored eyes. In an environment like the jungle, bright colored eyes would not be favorable to an organism. So these bright colored eyes organisms are likely to trickle down, and the neutral eye color is likely to survive and surpass the numbers. So the third finger we're going to do is the middle finger. So we're going to think M for mutations. Mutations can be good and mutations can be bad. So for the sake of the assignment, I am supposed to answer, what is an example of a good mutation? How does it contribute to evolution? So an example of good mutations can be milk. Us humans are not meant to process milk. And as a matter of fact, not being lactose intolerant is a mutation within itself. So us adapting and being able to process milk over the years is a good thing. Why is it a good thing? It's a good thing because we have a lot of dairy farms in the United States. So it's increasing the economic state of the world. That's one factor. Another factor is that dairy is extremely nutritious. We get a lot of our nutrition from dairy, and because of this milk, because we have access to milk, our nutrition levels are likely to increase and we have more options. It opens doors for us. So how does it contribute to evolution, I think, is the second part of the question. How does it contribute to evolution? So this contributes to evolution because the future of human species are going to be able to process milk. We're going to be able to process things that we couldn't before, which poses the question, what else can we adapt to? What other species' milk can we adapt to? So far, we're able to process cows, and what if in the future we're able to process other foods that we can't right now? So what that means is it opens doors for us, and it allows us to see short-term and long-term. We are able to gain adaptations, and we might be able to get more out of other organisms. So the fourth factor of microevolution, we're going to think a finger, the pointer finger. Where are you immigrating? Where are you emigrating? So where are you going into? Where are you leaving? So what this means is, if again, the Miami example, I moved to an area, I'm increasing gene flow. I'm pretty sure this finger has a question. Oh yeah. Why do humans all look different in terms of evolution? So there's a couple reasons why humans look different. For the answer of this question, I'm going to talk about genetic diversity, environment, and environmental conditions. So mutations, gene flow, our genetic background, all influences how we look. So if I live in Bronzeville, my ancestors are going to determine how I look. Another factor that influences how I look is where I live. Again, I live in Bronzeville, which is a semi-hot area, which is why my skin color is browner. If I were to live in an area where there's more exposure to sun, I would likely be a darker skin color. This is also adaptable to how I eat, my diet. So suppose that I eat meat. I do eat meat. My jaw is structured to eat meat, whereas in other cultures and in other countries, eating meat is not welcome. Eating meat is not the norm. So these people likely have a different jaw structure than I do. And that is another factor of why we all look so different. We all come from different backgrounds. We all have a long history of ancestors which determine how we look today. And there are also environmental factors that influence how we look. Where do we live? Is it hot where we live? What kind of food are we eating? All of these factors influence why we look so different, and it increases genetic diversity in the entire world. The last finger that I'm going to go over is the thumb. Is it a good thing or is it a bad thing? Natural selection, we're going to think thumb, good or bad. What traits are allowing you to survive and what traits are leading to your demise? So, pretty sure that there is a question for this finger. Yes. How does antibiotic resistance relate to this? So what is antibiotic resistance? Antibiotic resistance occurs when a bacteria adapts certain traits that allow them to be resistant to antibacteria. So antibacteria is meant to attack bacteria. It is meant to make us feel better. So bacteria is constantly reproducing, and it reproduces insanely quickly because of a process known as binary fission. Binary fission is bacteria splitting in half and gaining traits one from the other. So when this happens, it allows for a genetic background to be made much faster. So the genetic evolution process goes significantly quicker. When we introduce antibacteria, bacteria is going to learn how to reject the antibacteria, which is what antibiotic resistance means. So when it asks us, how does antibiotic resistance relate to evolution? It's bacteria evolving. Bacteria is evolving and it's becoming better, and it makes it harder for us as people to attack harmful bacteria. There is good bacteria and there's also bad bacteria that makes us sick, that causes us to be more prone to viruses. All these factors go back to evolution. At the end of the day, binary fission and the increasing of traits, you obviously are going to pass on better traits. You want to become a better organism. So bacteria are getting the best resistance and continuously multiplying, which leads to a certain bacteria that is completely antibiotic resistant. Thank you so much for listening to my video. I hope you guys learned a little bit about the 5 main causes of microevolution. Thank you so much.